Right, today we're going to learn how to program on the TI-83 Plus family of calculators just using a simple Pythagorean theorem program. I will be using my calculator on screen here. This one is a TI-84 Plus Silver Edition. I downloaded this at wabbitemu, or emu, I guess, .org. It is just a simple TI-83 Plus Silver Edition emulator used for Windows, Mac, or Android. You can download this onto your cell phone for use as well. We will begin just by working through the program. So on your calculator, make sure that you are at the home screen and click Program. This will bring up your programming menu. From here, this one is to execute any program, to run through it. This is to edit any program. This is to create new. So use your arrow keys, slide over to New, and click Create New. We are going to name this Pythagor, so P-Y-T-H-A-G-O-R, as in Pythagorean theorem. Click Enter. You have now created the program. Now we need to type everything in. As we are creating a new program, you will use the programming button to bring down your, again, programming menu. It's not the same programming menu as before because we're already in the program. From here, once you click it, we need to create a menu. So we will scroll down to find the menu. Where did it go? Here we are. This is telling the program that we're going to start off by creating a menu. We need to name the actual menu, so we will call it, in quotations, looking for. And make sure you have a space. The reason we're going to name it looking for, actually I'm going to put colon after that. This tells us, well, are we looking for either a leg or a hypotenuse? Because it depends on what formula you're going to use when the program runs through the Pythagorean theorem. So looking for, that's the title of the menu. Now you put a comma there, and you start going on all of the different options. So the first option would be if we were looking for a hypotenuse, so we will just type in hypotenuse. Oops. Can be rather cumbersome to do this on your calculator because you got to type everything in on your keypad. So it can take a little while. The next option would just be a leg, L-E-G. And hit enter at the end. So what we are telling the program right now is that we are going to choose between the two things we are looking for. Are we either looking for the hypotenuse, that's option A, or are we looking for the leg, option B? I shouldn't necessarily use the word option, these are labels. So label A is what happens when we're looking for a hypotenuse, label B is what happens when we're looking for a leg. Now to label different parts of your program, go back to the program, scroll down to label, hit enter again, label A. We are now telling the calculator or the program that everything from here on down is what happens when you go to A. So when you click hypotenuse, you go to this part of the program, and everything that follows is what this will run through. So from this part, after the user picks hypotenuse, we want to tell them exactly what's going to happen. So we're going to move over to the input-output screen, down to display, and we want to display a certain thing on the screen for them. We need to tell them that alpha A, remember this alpha is your typing in, so all of these green ones on here, it'll put in those the letters. A squared plus B squared equals C squared. So again, at that point, we're basically just reminding the user of what the Pythagorean theorem is. Next, we are going to prompt. Now to prompt, again, we go by that input-output screen, click on prompt, A, comma, B. we are telling the program that we need to input this value A, this value B. Now that's part of why we put the display up here. That way the user knows, oh, that's where A is, that's where B is. You just need to tell the calculator A and B. Once the program knows what variables A and B are, it needs to know what to do with said variables. So we need to create the actual formula. Square root A squared plus B squared, squared will be stored as C. Notice we don't use an equal here, we use this arrow key, STO. It's saying store this information as a variable C. We're going to do another one. A squared plus B squared will be stored as variable D. And you'll see why in a moment. But yes, we have square root of A squared plus B squared goes to C, and A squared plus B squared alone goes to D. Now that we know it is going to run the formula correctly, and we have told it here is the formula, here are the variables, we want to clear everything else off of the screen and start from fresh. So we go back to the input-output screen, down to clear home. That's the 8th option. That clears everything, and now we're able to start fresh. We're going to go to display again and type in that the hypotenuse is equal to hypotenuse is I don't want that now. We're going to put a blank line. So start your quotations, end your quotations. That'll just give us some space to work with. On the next line, don't use quotations and just type C. The program knows then use this variable C. Whatever value you have will be displayed on this line. So one line will say the hypotenuse is, blank line, value of C. We're going to do another blank line. We're going to begin again with, better do that. Or, another way to put it, and I'm going to put in my radical symbol, the square root symbol there. So again, hypotenuse is blank line, value of C, blank line, or with the square root of, and that should cover it for what we want displayed. In the next case, again, this time we can't do it as a display. Display will always just go one line after the other. Now we need to go to this input-output, scroll down to output. This will essentially overlay over anything that was already displayed. Again, text or values, whatever you want, and you have to do it in the right position. So we want 5th row, 5th spot, variable D. As long as you type this all in exactly like this output 5, 5 with D will put this variable D right after the square root part. In fact, it'll overlay it on top of this parenthesis, so we won't even have to close our parentheses. It'll just start the number right there and continue. After we have finished that output, I'm actually going to have it go pause. Everything will have displayed. We can see all of our answers. It'll pause for a second and wait for the user to click enter. After the user clicks enter, then it will stop. So I'm going to go again under the control area up to stop. You can scroll all the way down. You can also scroll all the way up. And it'll kind of come backwards, go to stop. This will end our label A. So this was the first part of our program. It will run through all of this, and this will figure out your hypotenuse. Now we've done everything we need to tell the program how to figure out a hypotenuse. We're going to do pretty much the exact same thing, only this time we're going to figure out the leg. So start everything all over again. We go back down to label B. So again, from our original menu that we created way up here, if you use A, we do everything we just did. But if you go to B, now it knows to jump down to this part. So we're going to have it do essentially, in many ways, the same thing. It's going to display the formula, so, oops, I wanted alpha A squared plus B squared equals C squared. So there again, it just displays the formula, the normal Pythagorean formula that we will use. Now we will have to prompt the pieces we want. Now we are going to tell it that we want B and C, meaning essentially we're solving for A. We are solving for one of these legs. Once we know what B and C are, again, we will just run the formula that C squared minus B squared will get stored as A. And similarly, if we do C squared minus B squared, I'm going to call that one Z for kicks. So again, this one had to have the square root in front of it, so it gets directly to A. This one does not have a square root piece in front of it, so that when we show Z, it'll say, or the square root of this, just like we did before. Now that we know what the formula is, we're just going to run through everything like we did before. Begin by clearing everything on screen and going back home. Next, we will display that, and again, you need to display with quotations, your leg is comma blank line comma A. So again, leg is blank line value of A, then another blank line, on the next line we'll say or it is or the square root of. Now we're done with our display. This time we need to overlay on the top of it. So we go down to output, fifth line, fifth spot. This time it'll be variable Z. Again, like before, we don't want it just to display and be done. So we will come down to pause. Once the user clicks pause or clicks enter to end the pause, then they will stop. This is our completed menu then, or sorry, our completed program. The entire code is ready to go. So now that we have it, we'll click second and quit. This brings us back to our home screen and we're ready to test it. So we'll begin by clicking programs. Now we will see in our execute line here, we can find the program that we created, Pythagor, click enter. To run the program, just click enter again. Here is that menu that we brought up. So this first time around, we will try it with the hypotenuse. We will test to see if we can find the correct hypotenuse. We will say that A in this case was 3, B in this case was 4. It'll run through everything, our formula, and tell us that 5 would be our hypotenuse, or the square root of 25. Which, obviously, yes, 5 is the square root of 25, so it worked for us. It says our program is done. I'm going to click enter again, and it runs our program again one more time for us. This time, I'm going to double check to make sure that the leg works. Notice we didn't have it clear home before. That's why it's naming everything down at the bottom. This one I think I had it clear home. But we're going to try different values. We know that the simple 3, 4, 5 works. Let's try a different kind of right triangle, a non-decent one, where the B value is 7, C value is 10. So this does not make a good Pythagorean triplet. Now we can see that the leg is more of an irrational number, 7.141428, blah, 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 or simply the square root of 51. So that does come out a lot easier, a lot better to look at it with this square root form instead of trying to look at this actual value. So that's why we put that piece into our formula or into our program here. Now that'll pretty much cover it.